And the first thing I wanted to point out, which should reflect on the entire day, is that climate change is nothing new. Since we've had an Earth, the climate's been changing, driven in large part by this amount of energy that reaches the Earth from the sun, which varies on some orbital cycles of the Earth on the order of tens of thousands of years. Plates have moved around, ocean basins have changed in size and shape, mountain ranges have come up and been eroded. Greenhouse gases, which are natural, have changed over time. So climate is constantly changing, but on long time scales. So today, as Sasha pointed out, we're on sort of a trajectory of climate change that may be a ramp, it may be a curve, convex up over time, and different scientists are using different models, different input parameters, whether it's temperature, sea surface, temperature, atmospheric temperature, precipitation, trying to look into the future. But there's some uncertainties in that, which will probably become clear through the day. One is what the natural climate variability is. Second is what greenhouse gases will do in the future, although maybe we should be heartened by all of the progress in Durban. We've agreed that we will talk about it until 2012 or 2020, and then maybe we'll do something. That's minimal progress, I would say, but at least they agreed to talk and communicate. And how the global climate system will respond to those future emissions. I wanted to quote one of my favorite climatologists. They're the known knowns, the unknown, or the known unknowns and the unknown unknowns, and certainly those all come into climate change. So there are certainly very hazardous events, what we could call extreme or catastrophic events that may not be climate related at all. These could be tsunamis from subduction zone earthquakes, they could be asteroid impacts, ocean overturning. And then there's the kinds of things that are more climate related that I think are more relevant in the short term. Major ENSO events, elevated sea levels, high tides, and so forth. I'm just going to show two graphics, and this spans the period from 2012 to, or today to 2050, and the second one will go for the second half of the century. And basically, these are meant to focus on risk, and risk is really the combination of the probability of an event occurring and the consequence or the magnitude if it does occur. So all I'm trying to show here is across the top is these events have a low probability of occurring between 2012 and 2050, a moderate, a high, or very high. And these are the magnitude. What happens if that does occur? Is it a disaster? And certainly I'll just say an asteroid impact, very low probability, but if it happens, it has a huge impact. Earthquakes and tsunamis, for example, have moderate probabilities of occurring. We had one in March, and moderate impacts on the coast of California, and I'll talk a tiny bit about that. Very high probabilities, cliffs are eroding daily, and so events happen commonly, and I'll just say for the time being they have moderate impacts. So the next image will look very similar. It just goes forward to 2050 to 2100, and all I will say is the issue of sea level rise and its inundation impact damages moves over into the likely very high probability with high impacts. Other than that, the other things stay pretty much the same, but it's important to keep in mind what risk really means, which is looking at those two issues. How likely is the event to occur, and what's the magnitude of the consequences? So certainly for California, because of our huge investment in the coastal zone, we have a lot of people, a lot of infrastructure virtually at sea level, in some cases below sea level. Anything that happens along the shorelines is going to affect a lot of investment, whether it's residents or whether it's some of the nation's largest volume harbors, which are by definition at sea level. This is just to make sure you're still all paying attention. What's there not to love about PowerPoint, right? You can do, or Photoshop, I guess. So just briefly, we formerly have thought there had been a few scattered asteroid impacts over time, but in fact there's been quite a number of them that we've discovered in recent years as we've looked more carefully. A lot of satellite imagery has helped. One that many of us know about is Meteor Crater in Arizona, which was quite small, 50 meters in diameter, 50,000 years ago. But the one that we've learned more about recently is Chicxulub in the Caribbean that hit about 65 million years ago, which I think the general belief is this did lead to the demise of the dinosaurs, wiped out about 35% of all species, and it left a huge crater. So these kinds of things do happen. It's not climate related. We don't know when those are going to happen. We have some idea as those things approach us. Another big event, again, that's not climate related but had an incredible impact 56 million years ago, and this has come from the ocean drilling program. We know, and I'm not going to show a lot of graphics, but this is the amount of carbon dioxide in the atmosphere from 400,000 years ago based on ice cores, and this is what we've been measuring at Kilauea in Hawaii, the increase of roughly 40% over the last 100 and something years. This is what happened when this ocean overturn occurred 56 million years ago. We're still not exactly sure what happened, whether it was warming related, whether it was undersea volcanism related, but we released an incredible amount of methane, carbon dioxide, and that content went up in the atmosphere maybe 700 parts per million quite quickly, which led to acidification, a lot of biological impacts. This might have been the warmest period in Earth's history. We have fossils of palm trees and alligators in the Arctic. We may have been completely ice-free. Sea level could have risen a couple of 100 feet. So that's, again, an extreme or a very extreme event. But that doesn't happen very often, although we're not quite sure what triggered it. Another issue that's not climate related, we had a big earthquake in Japan in March. This is actually an aerial view of the harbor at Santa Cruz. One of the two places that was hit pretty hard. You can see the tsunami coming into the harbor, and I think the total damage was maybe $30 million. Water funneled up into the harbor and did a lot of damage to the boats. Crescent City was the other area that typically gets hammered by tsunamis. Interestingly, in the last 200 years, even though when a tsunami occurs, it's one of those events we don't have any control over, there have only been 16 lives lost to tsunamis in California in 200 years. One during that event where somebody was standing out by the mouth of a Northern California river. That's like a good weekend of traffic in Los Angeles. Probably dog bites in California in a year. That many people die. I'm not down on dog owners. It's just probabilities are not very high, but when they do occur, they're devastating. Japan, on the other hand, had quite a different experience. The tsunami hit them very hard, and we've read and heard, and instead of little boats, big boats got moved around. So we have probably the highest likelihood of being hit by tsunamis from the Aleutians, from Japan, from the Western Pacific, although we have our own in our backyard, the Cascadia subduction zone, which many would consider overdue. So these are extreme coastal events. Something we don't often think of, large coastal landslides, again, not necessarily climate related, but could be if it's rainfall. Those of you from the northern part of the state will recognize Devil's Slide, which you may have driven across. Every time I drive across there, I hold my breath. We now have a tunnel that's bypassing this, and what's fascinating is they actually ran a railroad across here at the turn of the last century. There was an old railroad that was from San Francisco to Santa Cruz that they actually ran across that slide. La Conchita in Ventura County, just inland from the beach, failed in 2005, failed again in 1995, again in 2005. 10 people were buried under that slide. Torrey Pines, sort of in our backyard here, some very large slides, and looks like somebody's building right at the back edge of that. And even right here, virtually on the campus, beneath the National Marine Fisheries Lab, we've got a large slide mass. In fact, that building is now being rebuilt. So these are events that do also occur. I'm not sure we'd call these extreme. They're certainly large events. Something else that's a regular process along the entire California coast, cliff and bluff erosion ongoing, driven by both terrestrial processes, rainfall, seismic shaking, but also wave impact. Pacifica, 2010. This is not really bedrock. We can call it something fancy geological like quaternary alluvium or terrace deposit, but it's dirt, basically. And a lot of money was spent trying to pin this cliff back together. This isn't where I would invest. It's not where I would live. But this is going to happen more and more frequently up and down the coast. This is in Capitola. An interesting story here. I was called about 2 years ago by a real estate agent who had this apartment complex in escrow. And I work on coastal erosion, and this person said, someone told me to call you to see if there was any problems or any concerns. So he told me where it was, and I said, oh, is that the Antigua Apartments? And he said, yes, how did you know? And I said, well, you know, I know that area. And he said, do you have any concerns? I said, are you at a computer? And he said, yes. And I said, well, type in CaliforniaCoastline.org, and if you know the site, it's this incredible aerial photographic base of the whole state of California. It led to the Barbra Streisand lawsuit, you might have recalled if you keep up with Barbra Streisand. So he typed this in, and I put an image number in, and all of a sudden he got this up, and I heard this, oh, shit. So typical real estate agent, you know, they're standing up here on the deck looking over this scene, had no idea what was happening underneath them, which is a joint-bounded set of blocks that fail very regularly. And I don't know whatever happened, but it's typical of sort of the buying and selling and somewhat full disclosure in the real estate profession. If any of you have kids at UC Santa Barbara, you might want to see where they're living. This is Isla Vista, and this was taken in 2005. And two things noticed in the next picture is what happened here and what happened here. But basically, this is from the same photo site. Those decks are gone, and the front 3 or 4 units are gone, and the caissons ended up on the beach. So Isla Vista is a very rapidly eroding, not catastrophic events, just, you know, winter to winter. Solana Beach, 2002. 2010, so we can begin to see a lot of northern San Diego County are sitting on these vertical bluffs with fairly narrow beaches. And then we can see sort of the end result of that. 30% of San Diego County is armored. How much more will be put in is hard to say, but this has been one response to a retreating coastline. Our West Coast waves getting larger. A number of people have been looking at this question. Off Oregon, Washington, the trends from all the wave gauges, which don't go back that far, seem to indicate a significant increase in the highest waves, the largest waves. They're also occurring more frequently, and now some recent work has come out that suggests some of that may be artifacts of the buoys. But then there's also questions about increasing wind velocities that should be increasing wave height. So some uncertainties there. I'm not so sure off central and southern California. Some suggestion that wave heights are increasing, and again, our relatively short data record compared to, say, rainfall or temperature hinders us. This is just the number of times that waves larger than 16 feet or 5 meters or 6 meters or 20 feet have occurred since we've started keeping relatively good records in central and northern California. So on one hand, you could see this as an increase, but we also have climate oscillation cycles, Pacific decadal oscillations that may be affecting this. So I'm just putting this out there and saying this is something we need to keep track of. People like Ron need to keep track of waves. Sea level rise, short and long term. This is sort of a summary of 3 roughly 100-year periods going back into geologic time. Sort of, we can look at ice cores and tree rings and get some reasonable sense of how climate has changed and sea level rise parallels global temperature. We can look at tide gauge records, which actually extend back a bit further in time, for say 1900 up to the 90s. And now we have satellite altimetry, very precise. We get rid of the land problems. And then we can move forward into climate models and empirical projections where we look at global temperature and relate sea level directly to temperature. So you get some idea of what some of the likelihood may be out into the future. To begin to think about, this may be the most important image in this whole talk. And this is the curve for tide gauge at San Francisco. It actually goes back to the 1850s. But what's important here, we can see the long-term rise rate of about 2.1 millimeters per year. But in that record, you can see these major El Nino events that raise sea levels significantly for periods of days or weeks. So 1940-41, sea level was 11 inches or 280 millimeters above normal. 82-83 was the biggest and most damaging, perhaps in the last 50 years. Sea level was considerably higher for that period of time in 97-98. So you can imagine if you take this curve out at 2 millimeters a year, or 3 millimeters, or 4 millimeters, how long it takes till you get to that elevation. So short-term sea level rise is going to take a while to catch up with these short-term episodic events. And that's likely to continue, depending on the rate of rise, to at least mid-century. Same thing you can see in the San Diego tide gauge record. Here are these ENSO events that raise sea level 10, 20 or so centimeters for an extended period of time. Mission Beach, 1988. When you see a picture like this, these people standing at it, there's really no need to say anything, right? It's like, what are we doing here? And why are we this close to sea level? But it was a combination of some very large waves and some high tides, but I think it shows the vulnerability of large parts of the California coast to normal sort of events. This wasn't a long-term sea level rise event as much as it was the coincidence of very high tides and some large storm waves. The other thing that complicates this is that we know now that climate does oscillate over cycles of maybe several decades, this Pacific decadal oscillation. So we have these positive or warm intervals that are characterized by these ENSO events, and this went from, say, 1900 up to about 1945 or so. A cool interval, generally more benign conditions, fewer severe storms, fewer El Nino events. And then in about 1978, it switched back to a warmer, stormier, more erosion, more flooding. And what's interesting is that period of time, from roughly the end of World War II to 78, was when all of California's coastal development took place. Sort of like allocating all the Colorado River water during a time of lots of water. And so those people that built on the beaches and the bluffs and the cliffs built at a time when things were calm, and when the 78 El Nino and 82, 83 and so forth came along, there was a lot of surprises. So what happens next is going to be important, not only in terms of long-term climate change, but whether we're now into a different cycle, how that may affect sea level on the California coast, which has been depressed for a while, if it's going to start to rise at a faster rate. The January 83, January, February, March was what could be called the perfect storm. Damage from Humboldt County to San Diego, a lot of oceanfront homes destroyed, a lot damaged. What happened was the sea levels were higher than they'd been ever recorded in San Francisco, LA, and San Diego. So this was the predicted high tide at each of those four gauges, what was actually recorded and the difference. So as we went further north, sea level in Seattle was 2.5 feet above predicted. And then we had large waves, storm surge or wave run up. And this was in Monterey Bay. This is just the predicted tide level. So sea level is probably a foot or so above that. These are two wave gauges, one close to shore and one further out in the bay. So these are wave heights. But what you can see is each of these was a storm that hit at the time of a very high tide. So we had maybe 7 storms that hit at times of very high tide. It just happened to fall that way. 97, 98, they didn't quite coincide. We had a lot more seawalls in place. So these are the kinds of things I would say in the next 40 or 50 years that are going to be more damaging. And just to show you a few examples, this is a state beach park in Monterey Bay where people pull their campers out on the beach. And this restroom is in the next image here in '83. It's the bathroom down here. The campers are all gone. This is logs and driftwood that's been thrown over that bulkhead. At this point, I left. Did not look safe. And it was over a wall, a bulkhead that had been built 2 months before that was designed to last 20 years. Half of it was gone. In fact, if you look at a little bit lower tide, you can see out in the surf zone remains of earlier walls. In fact, you can go back into 1940 and you can see a whole string of walls. So this is a place where we've 8 times built walls that have been destroyed. This is a development also in northern Monterey Bay that was built out onto the beach, pre-coastal commission. They put some rock out here to protect them. And during the '83 storm, that acted like a ramp. And the waves went up that ramp through the front of their homes. That whole thing is now armored with a large 20-foot high concrete curved face seawall. So some of the coastal impacts of long-term sea level rise, we're now looking from 2050 to 2100, things we might expect: gradual flooding, more storm damage, increased cliff and bluff erosion, and finally beaches beginning to retreat, particularly where their back edges are fixed. Southern California, the edge of the continental shelf marks where sea level was at the end of the last ice age. Sea level is advanced in the LA area maybe 10 miles in that time, roughly 3 feet per year. How high, how fast might sea level rise? These are some curves Dan put together 5 years ago. These are in feet going out to 2100 using different emission standards and models. This is sort of what it was for the historic rate up to, say, 1990, roughly 8 inches over 100 years. This is the sea level altimetry present rate. And then Dan and a colleague just sent me a recent plot to show their more recent models, which mirror that pretty closely, roughly maybe 2 feet up to 4.5 feet or so by 2100. So those are things to think about. The Ocean Protection Council has adopted a series of sea levels by 2020 or 2030, 2050, 2100. State agencies and local agencies are beginning to use these now, and we can see a range of some pretty high numbers. Sea level alone, as I said earlier, probably isn't going to be a problem until at least 2050. This is San Francisco Airport with a 16-inch rise in sea level. The airport starts to go underwater by sea level rise alone. And I think Sasha showed also an earlier image of Balboa in a recent very high tide with not particularly large waves. So there's some areas of Southern California that may be inundated by mid-century. So our future through mid-century, coastal hazards will be no different than they have been in the past. They may be more frequent and more severe. Sea level rise alone will not cause significant flooding, inundation, or erosion by mid-century. And it's again going to be these El Nino events with elevated sea levels and large waves that are probably going to be the most problematic. And between 2050 and 2100, or when sea levels begin to approach, say, 18 inches or so above the present, we're going to start to see things like San Francisco Airport and other areas that are going to have to feel the impact, as well as beach loss, cliff erosion. And the last message is that coastal climate in the future will probably be characterized by variability with more extremes, uncertainty, and given those two, we need to continue to measure and monitor key variables to know really what's going on. What is local sea level doing? How are the waves changing? Cliff retreat, beach widths, and finally, all of our decisions should be based on long-term sustainability. Thank you very much.